Hello and welcome to this section. In this section, we will learn about data statistics. Similarly, we should first add an object container in the backend and change the name of the object container to our statistics. Then, let's learn about statistics in HeCode. First, let's create a new service. In fact, the final analysis of statistics is that we perform a series of statistical operations on the database through the service, so here, the object we choose is also one of our databases. Then there are actually a series of statistics at the bottom of the database. Let's give you a brief introduction one by one. Classified statistics is relatively complex, so let's talk about it at the end. Let's explain the previous several first. The first point is our statistical number. In fact, the statistical number has been carried out for you at the beginning. A simple explanation is that it counts some of the data it has in a field, and then finally gets a row number of the corresponding data. In order to facilitate our statistical demonstration, we add a field to the database. For example, after the status here, we add a column called its gender, and then click OK. Then we also write about the same gender here. For example, this is a boy, this is also a boy, this is a girl, and then this is a boy, then this is a girl, and then this is a boy. Let's click a saved modification. So it's equivalent to this. For 6 users like us, we give them some personality. Then let's count the number of people of some genders. For example, let's count the number of people whose gender is equal to 1. Then let's click a callback and set its return results through the current service area when it is completed. Since we count a gender here, there is a number of men here, and then there is a number of women here. If Unon counts a gender here, we can get a statistical result here. Let's debug and see that the returned result here is that the number of men is equal to 4. Since we want to count the number of men here gender, what should we do to count the gender of girls? There is a very simple method, that is, we can perform our statistics again. After clicking, we still select a statistical number, and then the filtering criteria here are the same. We select a gender, and gender is equal to female. Then we use a variable to transfer. When it calls back, we add a numerical variable, and then after that, there is the number of women, and then in the same way, we transfer the variables first, so that the assignment of the number of women here is equal to a result of our statistics, that is, a number of girls, and then in this way, through the unified return, we get such a number of women and return to the front end. Then let's debug and have a look. We can see the number of girls here, which is equal to y we want to copy. Oh, there is a mistake here. This is not a U21 parameter, but a statistical result in the drop-down menu. Therefore, we should count a statistical result of girls here, and then temporarily store a value for us quantity, and then set a return result here. Let's debug it again. We can see that the number of boys is 4, and the number of girls is 2. It is exactly the same as the data we just wrote in the backend. So this is our first usage, called our statistical number, and the name of our reform service is called statistical number. In the same way, we add another service. Let's learn his next action. Let's take a look at what the next action is. The next action is called counting the number of deleveraging. What is counting the number of deleveraging? That is, if it has duplicates, we will not calculate such a value, so what does it usually count? For example, let's count the total number of age groups, so let's count the total number of age groups here, and then select a field on this side as an age, and then we will return the same parameter. The number is called the age group. It is debugged through a callback. This is the current service, which is equal to our returned results. Let's debug. We can see that there are 5 age groups in total. Why are there 5 age groups? Let's have a look. You can see that 25 is an age group, 18 is an age group, 19 is an age group, 12 is an age group, and here is another 12. However, because it is a statistical deweighting number, 12 is the same age group for him, so there is number 12 here. Usually, there is another 45 here, so the statistical deweighting is if it needs to be repeated, it is only recorded as the same one, so we make a statistics on the age here, and the result is 5 age groups. Therefore, this is a scenario in which we use the statistical deduplication number. Let's give us so many names, count the deduplication number, and then add a service to our side, transfer one of our databases through it, and then transfer it to the next one. Let's call it a statistical sum. In fact, it's easier to understand the statistical sum, which is to count a sum of a certain field. For example, let's count the age here. You can see that in our drop-down menu, there are only 2 data IDs and ages for us to choose. Why? Because statistical summation is a process of summation. For our database, only if one of its variable types is numeric can it have the meaning of summation. Otherwise, if you are a variable of a string, how can it sum? Therefore, if we use statistical summation or statistics or average, we need it in advance. A field is a field of numerical type, so such a statistical sum can be used directly in this way. You can see that the total is 131. Although we didn't do a simple search here, it's about the same. Then let's say an extra word here, that is, all statistics can be established under conditions. For example, we can preset here. For example, his age should be greater than 40 years old. I want to count the sum of ages greater than 40 years old. Let's debug it. We can see that the total is 45. We can check it in the database. We can see that there is only 45 over the age of 40, so the final statistical result is 45. It's convenient for us to test here. We adjust the age to more than 20. Let's have a look again. At present, it seems that if we adjust it to more than 20, there are only 125 and 145. Let's change it again, and then think that a 20, and then choose a debugging. We can see that the sum of ages is actually the same as we expected, so here is a method of statistical sum. Then, similarly, we can make our service count its average value. Here we can choose a database. We can choose a method of counting the average value, and its screening conditions. Here, we just need to add an average value. For example, we want to count the average value of people older than 40, and then we choose one in the value field. The following is our age field. We call back to return an average. They pull a feedback result from the drop-down menu. The average is a statistical result. Let's take a look. There is only one person greater than 40, so it is 45 per person, so the average is 40. Similarly, if we change it to 20, it is the same. The average is 35, because we have just seen it in the database. There is a 25 person and a 45 person older than our 20 years old. The calculated result is 35. Similarly, if we do not add any conditions, he will count the average age in the whole. So let's change the name here. Here is our statistical average. Of course, after the statistical average is completed, we can talk about the most complex one. In fact, the most complex one is our classified statistics. We add a service called our classified statistics. What is classified statistics? In fact, it is to make statistics according to categories. Come here to make statistics according to categories. I have set some scenes for you. Let's have a look. If you encounter such a problem, how do you make statistics? The first question here is how many people are men and women? If you ask such a question, that is, how many men and women each account for, how do you make statistics? Just now, have we actually made a statistics on the proportion of men and women here? Because why can we do this here? Because we know that there are only 2 options for gender, men and women, so here we count the number of a woman and a man, and then finally get each number, we return it, but what if it has a different result? Let's take the proportion of men and women as an example. Let's think about how to make statistics for such a result. When we arrive, we add a return parameter to make a statistical result. Since we want to use classified statistics, we still need to click one of our databases, and then we select such a classified statistics in the drop-down menu law. When we do top-level classification statistics, there are also filter criteria, list and classification columns, as well as sorting method and output row number. This is the same as the output method we usually see. So we understand that when we use a classification statistics, what is returned to the front end is actually an array, and then let's do such a method first, which is called how many men and women account for each other. Please note that whenever a classified statistics is involved, the most important thing is that you should understand what we want to classify according to, and what are men and women here. Men and women are gender, right? So our classification column, let's choose it first. What is it? A distinction is made according to our gender, so in the classification column, we choose the gender equal to ours, and here we can ignore it. So the next step is output. What are we going to output? In fact, if we want to see how many men and women each account for, we can make statistics according to their number, so we can still choose our gender in the field we choose here. What is the statistical method? We need to count the number of people of each gender, so here we want to select a statistical number, so it is equivalent to that here we make a statistics of a gender according to its gender. But a student association said that it depends on the number of men and women. I think it's too troublesome for you to understand this. It's really better for you to see that the number of statistics in front of me seems more intuitive. Why do classified statistics still exist? This is because, in fact, there are not only two cases of classified statistics. Let's take another example here. For example, there is a new demand for you to count the age composition of students. What is the age composition? Maybe the whole students are 18-22 years old. Then he asked you how many people are 18 and 22 years old. Maybe the age span is a little larger, and maybe 48 years old, then you have to count how many people are 48 years old, so it is impossible for you to count all the values of 1848 here, and then return them. So in this case, we will use one of our classification statistics. So next, let's do something about how to do the next service, that is, how to count the age composition of students. In the same way, let's first select one of our databases, and then let him perform an operation of classified statistics. Then, the first point we want to distinguish is what its classification column is, what it uses as a distinction. Age as a distinction, right? So what is its classification? It's our age. Here we're going to count its age. What's his age? It's not a statistical sum, nor is it a statistical average. What is it? It's a number of statistics at this age, so here we still choose it as a statistical number. Then the method we learned just now has been told to you, in order to intuitively show its age range. Therefore, we will choose another age here, and make statistics through the method without method, which is equivalent to show such a field, and then, in the same way, let's count a value of an object array of its statistical results through the current service. Let's click debugging. We can see that the age is 25, one is 18, one is 19, one is 45, and 2 are 12 people. Does this correspond to a series of information in our database one by one? Therefore, this is actually the most important purpose of our classification statistics, that is, we can have many kinds, which can be distinguished according to different types. Therefore, generally speaking, there will be such a scenario. For example, you need to count the login of a user in the last 3 days, so the login time is equal to the last 3 days, then you have to count the number of people, so you will also use one of our classified statistics to complete a production. Okay, then after completing this step, let's finally practice one. You can also write it for a long time, and look at the answer. Next, let's take a look at the average age of male and female students, the average age of male and female students, which is actually a very, very typical method of classified statistics. In the same way, we should first select one of our databases, and let it perform a practice of classified statistics. First of all, let's be clear, that is, the average age of male and female students. What is the difference? Right? Male and female students. What are male and female students? It's a gender, so we still choose a gender for its classification column. Then, what is the next distinction? Is it an average age as the atmosphere? So what should we choose here? What is its age? Average age, so what is the statistical method? It's one of our averages. Then, through the introduction just now, we have understood that whenever I use which is our classification column, we'd better select such a classification in the output column to facilitate us to check. Therefore, here we are selecting a gender, then not a statistical method, and then complete a return with us to set it through the current service result, a value of an object array equal to the statistical result. Then, let's debug and take a look. We can see that the statistical result here is that the average age of girls is 15.5 and the average age of boys is 25. Here we can check and calculate a little. Let's check and calculate the age of girls. To switch to such a table, we can see that girls include one of our top 4 and Aston, one is 12, the other is 19, the average is 15.5, right? Therefore, in fact, our classified statistics, there are many such scenarios for you to make statistics. Then, of course, it's very simple to add a series of conditions for classified statistics here. For example, the average age of male and female students who are older than 18 years old. Then you can choose an age judgment here, and let them be older than 18 years old. Then we can make another statistics. We can see that the average age of a female student who is older than 18 years old is 19 years old, and that of a male student the average age is 35, so this is a practice of classified statistics. In fact, classified statistics should be used more. Only by using more can you better understand such a series of practices. Then the basic principle is actually like this. The above is the whole content of this section. Thank you for watching.